Hello everyone, welcome to our channel. Today we will discuss about biomolecules and carbohydrates part 1. Carbohydrates. Carbohydrates means hydrates of carbon. It means they contain carbon, hydrogen and hydrates. It means water molecule. So for example, you can see glucose. Its structural formula is C6H12O6 and it contains 6 carbon and 6 water molecules. So it is called as hydrates of carbon. So generally carbohydrates are denoted with the formula CnH2O times. So scientists first they get this method to prove whether a given compound is a carbohydrate or not. So that's why they classified the compounds which satisfy CnH2O times. So they classify the carbon atoms under carbohydrates, and the compounds which do not satisfy CnH2O times, so they classify them under as non-carbohydrates. But after some studies it came to know that some compounds which satisfy the formula are not comes under carbohydrates. For example, if you consider formaldehyde, the molecular formula is HCHO. So it can be write it into the formula as CH2O. It means N value here is 1. And another example is acetic acid, CH3COOH. It can be write in the formula as C2H2O twice. Here N is equals to 2. So these two carbon atoms are satisfying the formula of carbohydrates like CnH2O n times, but so they are not carbohydrates really. And some of the carbohydrates are there which do not satisfy the formula, but they will act as carbohydrates and they show the properties of carbohydrates. For example, rhamnose, its formula is C6H12O5 and it cannot be written in the form of CnH2O times. So there the scientists have come across some of these problems, like some satisfy the formula but not carbohydrates, but some do not satisfy formula but they are carbohydrates. To avoid such confusions, they come into a conclusion to define what are really carbohydrates is. So they can be better described as optically active polyhydroxyaldehydes or ketones. So it means optically active, it means it should have optically active chiral carbon, and polyhydroxy, it contain number of water molecules or hydrogen molecules, aldehydes or ketones. So it must contain an aldehyde group, C double bond O or H group, or a ketone group, C double bond O or R dash groups. So finally the scientists came into understand, so it can be better described in this definition as optically active polyhydroxyaldehydes or ketones, or the compounds which yield them on hydrolysis. Okay, so this is the pure definition of carbohydrates. Next, most of them are similar to sugar in taste. Carbohydrates are, most of them are sugar in taste, and hence they are also called as saccharoids. So carbohydrates are also called as saccharoids. So the name saccharoids itself is taken from the Latin word saccharum, which means sugar in taste in the Latin. Next we will see about classification. So carbohydrates according to hydrolysis, so they are classified into some of the groups. So hydrolysis means when a carbohydrates react with water, so it undergoes hydrolysis. So first type is monosaccharides. So what are monosaccharides means? So they cannot be further hydrolysis into simpler molecules. So if a molecule is reacted with the water and it does not divide into any further molecules, so those comes under monosaccharides. So the examples of monosaccharides are erythritose, threose, glucose, galactose, fructose and ribose. So these structures we will see in the next classes. So every structure I will be clearly explained, and these comes under the monosaccharides. So there are about 20 monosaccharides that occur in nature, nearly 20 are there, and their general formula is CH2O n times, where n moves from 3 to 7. So those comes under monosaccharides. So depending upon the total number of carbon atoms in the monosaccharides and on the nature of functional group present, So like aldehyde or ketone, the term for their classification is done in the following. So I will show you a table, so clearly note it down. If the monosaccharide contains 3 carbon atoms and its general name is triose, and if it contains aldehyde, it is called as aldotriose, and if it contains ketone, it is called as ketotriose. And if the monosaccharide contains 4 carbon atoms, its general name is tetrose, and if in case it contains aldose, it can be called as aldotetrose. In case if it contains ketose, it is called as ketotetrose. In this way it can be named, and you can see up to 5, 6, 7, 8 carbon atoms in this table. Okay, that's about monosaccharides. And if you move to the second classification, it is oligosaccharides. So these undergoes hydrolysis and yields 2 to 10 monosaccharide units. Monosaccharides gives no units, but oligosaccharides can give up to 2 to 10 monosaccharide units. So that's why these oligosaccharide is further again divided into 3 subgroups. It is the disaccharides, trisaccharides and polysaccharides. So in the name itself, if you see disaccharides, so a disaccharide is a carbohydrates which on hydrolysis gives 2 monosaccharides units of same or different kind. So for example, if you see the disaccharides, so there are 3 main examples: sucrose, maltose and lactose. If you take lactose and react with water or its hydrolysis, it gives glucose plus galactose. If you take sucrose and on hydrolysis, it gives glucose plus fructose. And if you take maltose on hydrolysis, it gives glucose and another one also glucose. Okay, so this about disaccharide, and a main equation is involved in the disaccharide. It is, if you take sucrose and you hydrolysis, it will give glucose plus fructose. So you can watch it in the down: C12H12 H22O11 plus H2 on hydrolysis gives C6H12O6 plus C6H12O6. So it's about disaccharides. And if you come across trisaccharide, so a trisaccharide is a carbohydrate which on hydrolysis gives 3 monosaccharides units. As of now, we have one example. It is raffinose. So raffinose on hydrolysis gives 3 monosaccharide units. It's glucose, fructose and galactose. Okay, and it's about trisaccharides. And if you take polysaccharides, so these undergoes hydrolysis and gives more than 3 monosaccharide units. So those are called as polysaccharides. And it also has a general formula C6H10O5 N times. And some of the examples of polysaccharides are starch, cellulose, glycogen, dextrin and gums. And there is a famous equation: C6H10O5 N times on react with NH2O water molecules in the specified condition 2 to 3 atmospheric pressure and 393 Kelvin, it gives an C6H12O6 molecule. Next classification is sugars and non-sugars. So here both monosaccharides and oligosaccharides are crystalline solids. They are soluble in water and sweet in taste. So they are collectively known as sugars. And polysaccharides are amorphous, sparingly soluble in water, and they are tasteless and are known as non-sugars. So in this way, the monosaccharides, oligosaccharides are classified as sugars and non-sugars. And next type of classification, the carbohydrates are also classified as reducing and non-reducing sugars. See here, the saccharides that reduces Fehling's reagent and Tollin's reagent are called as reducing sugars. So they form silver mirror with Tollin's reagent and red precipitate with Fehling solution. So all monosaccharides, whether aldose or ketose, are reducing sugars. All reducing sugars exhibits mutarotation. So about mutarotation we can further discuss in the classes. And the examples are glucose, fructose, triose, tetrose, pentose and hexose. All disaccharides are reducing sugars except sucrose. And all polysaccharides are also comes under non-reducing sugars. So example, maltose and lactose. The saccharides which do not reduce Fehling's reagent and Tolling's reagent are called non-reducing sugars. All polysaccharides are non-reducing sugars. So example, starch, cellulose, glycogen, dextrins. Non-reducing sugars do not exhibit mutarotation and they also do not form ozones. In disaccharides, depending upon the position of linkages, disaccharides may be reducing or non-reducing. DL isomerism. The stereochemistry of all sugars is determined with respect to D or L glyceraldehyde. Sugars can be classified into D and L forms basing on their configurations. So you can see there are two molecules on the screen. So in which OH molecule in the first is on the right side of the carbon, and in the second molecule OH is in the left side of the middle carbon. So if the OH is in the right side, it is called D, and if the OH is in the left side, it is called as L. So in this way we can write DL configurations. The enantiomers which rotates the monochromatic light to the right is written as plus or small d, and otherwise which rotates the monochromatic light to the left is written as minus or L. So here enantiomers means, so those are mirror images to each other and non-superimposable. It means if you open your both palms, so and if you attach this, so they can be visualized as mirror images, and if you keep your one palm on the other palm, they would not superimpose. It means the every finger will not exactly fit. So one thumb finger will come one side and other thumb finger will come on other side. So it is called as enantiomers. The direction of rotation of monochromatic light can be denoted by plus or minus, but cannot indicate the arrangement of OH or H around the chiral carbon atom. Here chiral carbon atom means middle carbon atom because it has 4 different group of atoms around it. Any carbon containing 4 different atoms around it, it can be called it as chiral carbon. The middle carbon is called as chiral carbon in the two molecules in the DL isomerism. So your first molecule is called as D-glyceraldehyde because OH is on the right side, and the second one is called as L-glyceraldehyde because the OH is on the left side. So Rafnos, he is a scientist, he proposed a system to designate the stereochemistry of carbohydrates by considering the simplest sugar, glyceraldehyde, as a standard. Okay, the sugars having the same configuration as D-glyceraldehyde, at least periodic chiral carbon adjacent to primary alcohol group CH2OH are called as D sugars, and having the configuration as L-glyceraldehyde are called as L sugars. Practically D sugars may be capital D plus or capital D minus, and L sugars may be capital L plus or capital L minus. The symbol plus or D used for dextro and minus or L is used for levorotatory compounds. It is observed that natural glucose, ribose and fructose are D forms. And the last one is erythro and thrio. Two older prefixes still commonly used to distinguish diastereomers. So diastereomers means non-superimposable and non-mirror images. Are thrio and erythro in case of carbohydrates when drawn in Fischer projection. Fischer projection means whatever you are seeing on the screen. So those are called as Fischer projections. The erythro isomer has two identical substituents on the same side, and the thrio isomer has them on the opposite side. If you see threos, so one side of its threos has OH and H, and other side also has OH and H. But erythros, if you consider, on the right side it has 2OH and on the left side it has 2H. So for example of diastereomers and enantiomers, I will show you simple example with my palms. Observe carefully and remember it. Let us go and see it. Enantiomers. So if you consider your both palms, so if you can place it in the side by side, so you can observe these two are like mirror images irrespective of lines in my hand. So if you can see, these both are like mirror images. This is mirror image to this and this is mirror images to this. and if you place it your one hand on the other hand, so it does not superimpose. See, it does not superimpose, so the fingers does not superimpose. So that's why these are called as enantiomers, mirror images to each other but does not superimpose. Stereomers. If you consider my these two hands, so these are non-mirror images and non-superimposable. So these type of compounds are called as diastereomers. Okay, that's it for today's video. So please like, share, subscribe and share it to everyone. If you have any doubts, please comment in the comment section. Don't hesitate to ask anything. Thank you, bye bye, and don't forget to subscribe on your bell button. Thank you. Have a nice day.